Okay, so let's start off where we left off. Here's another example of a power, current, and voltage problem. If a fuse blows out at 15 amperes in a United States home, so we're in the United States, what is the maximum amount of power that the fuse can handle? So, I'll give you guys a bit of time to try this out. So pause the video at this moment. So when working with this problem, we know that we're working with 15 amps at a max. We're in the United States, so our voltage is 120. That's the value that we saw in our lab, and that's the value that we're working with whenever we're working with an outlet in the United States. We multiply 15 by 120, and we get that the power that we're working with at a max is 1,800 watts. Let's look at one last example. A 100-watt light bulb is plugged into a 9-volt battery. What would be the current running through the wire? So pay close attention to what I gave you in this problem and figure out what you need to solve. I'll give you guys a moment to answer this problem. You should pause the video at this time. Okay, so this problem's a little bit tricky because I give you a power and a voltage. So you need to rearrange the equation so that it's power divided by voltage equals current. So we need to do 100 watts divided by 9 volts in order to get our final answer of 11.11 amps. We're still using the same equation, we're just rearranging it so that we're solving for current rather than solving for power. And this is a skill that we're going to have to know. I could have used it in the energy equations. I could use it in one of these. Sometimes it's not just plug and chug. We're going to have to rearrange the equations a bit in order to solve for what is missing. The last equation that we looked at in this class was efficiency. So how well something is able to convert energy from one source to another. So the energy supplied to the energy used, or the power supplied to the power being used. I used the metaphor of the bike for this example. If we had two different bikes, one with the rusted chain and one with the greased up chain, and we put the same amount of energy into trying to ride both bikes, the greased up chain, the amount of energy we put in is going to take us farther. So that's a more efficient bike. Whereas if we had the rusted chain, it is less efficient, or it's not going to take us as far. So let's look at some examples using this idea of efficiency, how well energy or power can be transferred from something supplied to being used. If an electric scooter is 30% efficient, how much of the 500 joules used to charge it will be used to make it move? So we have 30% efficiency and 500 joules that we put in originally. So let's try and solve this problem out. Pause the video at this moment and let's give it a whirl. Okay, so with this problem, our efficiency is 30%. But remember, we can't leave it as 30 in our equation. The efficiency needs to be a decimal. So here, instead of writing 30, we'd write 0.3. Our energy supplied, so how much energy we had in the beginning, was 500. But we're looking for how much we're actually going to be using in order to make the scooter move. So it's 30% efficient, so if we multiply the 0.3 by the 500, we get that our final answer is 150 joules of used energy. Let's look at one last example. If a home receives 200 kilowatt hours of energy from the power plant, but there is a 5% loss of energy during the transfer process, how much energy was the house supplied? So we're using that same equation, but remember, read the question carefully there is a 5% loss of energy. So pause the video at this time and give this problem a try. Okay. Here, our efficiency is 95% because there's a 5% loss of energy. So we have that 100 minus the 5% loss, leaving us with 95%. When we write that as a decimal, that's 0.95. We know our used energy is 200. So when we solve for the supplied energy, we should get 210.5 joules is what we had in the beginning if there was a 5% loss and we ended up receiving 200 joules. So at this point, we've covered everything that will be on the exam. You could expect that some of the level 1 questions would be of a slightly higher difficulty, but as a baseline level 2 material, in terms of just the concepts, everything has been covered here. So if you feel comfortable after watching this video and doing these problems, you're going to be in a good spot for the upcoming quiz. There will be further examples I'll be giving you guys that you guys can run through, but you should be able to assess at this point how prepared you are coming up to the material and which of these 3 parts, whether it's the energy, the current and voltage, or if the efficiency parts are giving you the most trouble, and focus on those parts throughout the upcoming week. Best of luck, and I'll see you guys super soon.